has less isolation as more resources are shared between the containers, like the kernel, whereas VMs have complete isolation from each other. Since VMs don't rely on the underlying OS or kernel, you can run different types of applications built on different OSs, such as Linux-based or Windows-based apps on the same hypervisor. So those are some differences between the two. Now, having said that, it's not an either container or virtual machine situation. It's containers and virtual machines. Now, when you have large environments with thousands of application containers running on thousands of Docker hosts, you will often see containers provisioned on virtual Docker hosts. That way, we can utilize the advantages of both technologies. We can use the benefits of virtualization to easily provision or decommission Docker hosts as required, at the same time make use of the benefits of Docker to easily provision applications and quickly scale them as required. But remember that in this case, we will not be provisioning that many virtual machines as we used to before, because earlier we provisioned a virtual machine for each application. Now you might provision a virtual machine for hundreds or thousands of containers. So how is it done? There are lots of containerized versions of applications readily available as of today. So most organizations have their products containerized and available in a public Docker repository called Docker Hub or Docker Store. For example, you can find images of most common operating systems, databases, and other services and tools. Once you identify the images you need and you install Docker on your host, bringing up an application is as easy as running a Docker run command with the name of the image. In this case, running a Docker run Ansible command will run an instance of Ansible on the Docker host. Similarly, run an instance of MongoDB, Redis, and Node.js using the Docker run command. If we need to run multiple instances of the web service, simply add as many instances as you need and configure a load balancer of some kind in the front. In case one of the instances were to fail, simply destroy that instance and launch a new one. There are other solutions available for handling such cases that we will look at later during this course. And for now, don't focus too much on the commands. We will get to that in a bit. We've been talking about images and containers. Let's understand the difference between the two. An image is a package or a template, just like a VM template that you might have worked with in the virtualization world. It is used to create one or more containers. Containers are running instances of images that are isolated and have their own environments and set of processes. As we have seen before, a lot of products have been Dockerized already. In case you cannot find what you're looking for, you could create your own image and push it to Docker Hub repository, making it available for public. So if you look at it, traditionally, developers developed applications. Then they hand it over to ops team to deploy and manage it in production environments. They do that by providing a set of instructions, such as information about how the host must be set up, what prerequisites are to be installed on the host, and how the dependencies are to be configured, etc. Since the ops team did not really develop the application on their own, they struggle with setting it up. When they hit an issue, they work with the developers to resolve it. With Docker, the developers and operations teams work hand in hand to transform the guide into a Docker file with both of their requirements. This Docker file is then used to create an image for their applications. This image can now run on any host with Docker installed on it and is guaranteed to run the same way everywhere. So the ops team can now simply use the image to deploy the application. Since the image was already working when the developer built it and operations have not modified it, it continues to work the same way when deployed in production. And that's one example of how a tool like Docker contributes to the DevOps culture. Well, that's it for now, and in the upcoming lecture, we will look at how to get started with Docker.